All right, so let's go ahead and get started with this. This is going to be lecture 25 on the normal distribution. So the normal distribution is the most important distribution in all of statistics. What it is it's a bell-shaped curve. We call it the bell curve. It's going to be defined by the mean. Mean is another word for average. And the symbol that we're going to use for mean today is going to be the Greek letter mu. We're also going to use a letter called standard deviation. Standard deviation. The symbol for this is going to be the Greek letter sigma. The mean is going to be the line of symmetry. And when I say line of symmetry, I'm talking about the middle line that divides the curve in half. So a couple more things about the normal distribution that you should know. This is going to be a probability distribution. On the y-axis, you're going to see all the probabilities. And on the x-axis, which is the horizontal axis, you're going to see all of the standard deviations. Another thing we can say about this, the total area under the curve will always be equal to 1. So the total area under the curve is 1. Okay. So one more thing that you should know about this, the normal distribution is going to follow what's called the 3 sigma rule. So let's talk about standard deviations. What you'll see up here is there's going to be a -1 sigma and a +1 sigma. 68% of all the data is going to fall within 1 standard deviation of the mean. So beside 1 sigma, I'm going to write 68%. It's actually a little bit more than that, but I'm going to round it down to 68%. If you look at 2 standard deviations, that's going to be from -2 sigma to +2 sigma. The total area within 2 standard deviations is going to be 95%. So that's almost all of it. So 2 sigma is going to give you 95%. And then 3 sigma, that's going to be 3 standard deviations. So that's going to be from -3 sigma to +3 sigma. And there's more after that. But between -3 and +3, you're going to have 99.7% of all the data. So the vast majority of the data is very close to the mean. So within 3 standard deviations, you're going to have 99.7% of all the data. That's called the 3 sigma rule. Okay, So that is the normal distribution. We're going to hop on Desmos in a minute, and I'll show you how to use the normal distribution on there. But before that, I wanted to watch a video. This is going to be under modules. And this is called the Galton Board. And I'll just play it and let you watch. So what you see here is you see a bunch of tiny metal balls. When he flips the Galton board, they all go back down into its container right there. And then when he flips it over, all these little metal balls are going to go through these little pins right here. And when you slow it down, you can see that most of them are going to be very close to the center right here. And only very few of those are going to go farther away from the mean. So you can watch that later if you want. That's called the Galton board. Okay, so we're going to go over to Desmos now. And what I'm going to do is I'm going to click in the first box. And you'll see that box 1 is now highlighted. So what you're going to do here is you're going to go to the bottom of the screen where you see the keypad. It'll say show keypad. We're going to click that. And then what we're going to do is we're going to go all the way to the right to where you see functions. Go ahead and click the functions button. And then at the top, you're going to see 4 different menus. You're going to see trig, stats, distribution, and miscellaneous. We're going to go to distribution. And then under that, you'll see visualizations, distributions. We're going to click on normal, DIST. That's going to be the first distribution that you'll see. So go ahead and click on that. And when you do that, in box 1, you'll see normal DIST. And if you ever want to bring that up, all you have to do is type in normal DIST, and it'll bring up the normal distribution. Okay, so in box 1, you can choose the mean, which is the average, and you can choose the standard deviation. When you start off with this, the mean is automatically going to be 0. So this is the mean right here. The standard deviation is automatically going to be 1 when you get it started, but you can change these numbers if you want. But right now, for our purposes today, I'm just going to leave it as it is. So the average is going to be 0, and the standard deviation is going to be 1. Now, inside the parentheses right here, you'll see my little cursor flashing on and off. You can type in the average that you want. So I'm going to type in 0, and then a comma, and then a 1. And that just means that the average is going to be 0, and the standard deviation will be 1. Okay, so now what we're going to do is we're going to click the magnifying glass that's at the bottom of the box. This is zoom fit. And what that's going to do is it's going to zoom into the normal distribution so you can see it a little bit better. What we're going to do next is we're going to check the box that says find cumulative probability, CDF. CDF stands for cumulative distribution function. So we're going to check this box right here. And when I check the box, the total area under the curve, which is equal to 1, is going to all be shaded in the color that you chose. And you can hold down your cursor on this icon right here, and you can choose a different color for your normal distribution. but I'm going to leave mine red for now. Also, down here, you'll see min and max. Min stands for minimum, max stands for maximum. These are going to be your upper and lower limits. So right now, I don't have anything written down for the minimum and the maximum. So if I don't have anything written down here, it's going to automatically be negative infinity and positive infinity. And that means that on the x-axis right here, if you go far enough to the left, you're going to reach negative infinity. But if you go far enough to the right, the numbers get bigger, you're going to reach positive infinity. Okay? And then the area under the curve that's shaded is going to be at the bottom of the box. So the total area under the curve right now is 1. But we're going to change that. Okay, so for minimum, I want you to click on the minimum, and I want you to type in -1. We're going to type in a -1. And what you'll notice is on the graph, the -1 is going to be right here on the x-axis. So -1 is going to be your lower limit. And then the upper limit, the maximum, we're going to click on that, and we're going to put a +1 right there. So 1 is going to be my upper limit. So now on the x-axis, you'll notice that only this portion below the normal distribution is shaded. So what percentage of the area is shaded? That's going to be, yep, this decimal right here. It's 0.6827 if I round. So if I write that down, it's going to be 0.6827. So that 8 is going to tell that 6 to go up to a 7. And now what I can do with this decimal is I can write it as a percentage. The only thing I have to do for that is take this decimal point and move it to the right twice. So I'm going to go 1, 2, and now it's right here. So this is going to be 68.27%. And what that means is about 68% of the data is shaded right now. 68% of all the area under the curve is shaded. But we want to do a little bit better than that, right? So now let's see what happens when we're 2 standard deviations away. Under minimum, I want you to change that -1 to a -2. And we're going to change the maximum to +2. Okay. So now what you'll see is almost all of the area under the curve is shaded. What's the decimal that I get? Yeah. 0.9545. So the way I would write this as a decimal is with 4 decimal places. I look right here and I have 9545. So 9545. So this 9 right here is telling this 4 to round up to a 5. So I get this decimal. And then if I want to write it as a percentage, I'm going to take this decimal point and I'm going to move it to the right twice. So I get 95.45%. And what that means is about 95% of all the area under the curve is shaded now. And that's between 2 standard deviations from the mean. All right, the last thing we're going to do is we're going to change the minimum to -3. And we're going to change the maximum to +3. So now we're 3 standard deviations away from the mean, the axis of symmetry. What decimal does it give you now? Yeah, 0.99. And then the last 2 digits are going to be 73. And that 0 is going to tell that 3 to stay put. So if the answer asks for a decimal, that's what I'm going to write. If the question asks for a percentage, I'm going to move this decimal point to the right twice. So now I have 99.73% of all the data shaded. And it's that remaining 0.27% that is beyond the shaded region. It would be like right here or right here. You just really can't see it. But if you zoom in, I bet you could see it. So I'm going to zoom in, and what you'll see is once you get past 3 standard deviations, this little bit of the data is going to be the 0.135%. So I'll hit zoom fit again. Now I see my curve. And now I'm going to zoom in on the right side. And it's this little bit, the 0.135%, that does not get shaded. So the vast majority of all the data gets shaded at this point. So now what we're going to do is we're going to change our minimum and maximum again. What we're going to do is we're going to get rid of our minimum limit. So I'm going to backspace all of this, and I'm going to get rid of my maximum limit. And what you'll notice is when you do that, and then you click away from the box, it'll automatically become -infinity and +infinity. So now all the area under the curve is now shaded. Okay, so now on a separate sheet of paper, we're going to try the problem set. Let's take a look at what that says. Okay, so the first problem says a normally distributed data set of 200 values has a mean of 68 and a standard deviation of 6. Those are 2 very important numbers. So I'm going to write those down on the board. So the mean is the same thing as the average, right? So I'm going to say the average is 68. That's going to be my axis of symmetry when I go back to Desmos. And then the standard deviation, the sigma, is going to be 6. So these are the 2 most important numbers that I can get. So now what I'm going to do is I'm going to go back to Desmos. And for the mean right here, I'm going to get rid of the 0, and I'm going to type in 68.
Why is it 0.1?
1 down here.
You just keep with 1 no matter what.
Yeah. So 68 is going to be the first number inside the parentheses, and then there's going to be a comma. And now what we're going to do is we're going to get rid of the 1 for the standard deviation, and I'm going to replace that with a 6 because that's what the question says. So now I've got normal distribution 68,6. Now, I can't really see the bell curve that well, so I'm going to click on Zoom Fit at the bottom of the box. And now I can see it again. So what you'll notice about this is the average is 68. That's the mean. It's going to be right in the middle of the curve right here. So this line is going to be 68. And then the standard deviation is going to be on the x-axis away from the mean. So now, what is our minimum limit and what is our maximum limit? Let's check and see. So the first question says, what percentage of the values is between 61 and 75? So what that means is the 61 is going to be the minimum and the 75 is going to be the maximum. So 61, 75. So I go back here. My minimum is going to be 61. I type that in. And then my maximum is going to be 75. And then you can see how much of the area is actually shaded. This much right here. So 61 is going to be right here. That's my minimum. 75 is going to be my maximum limit. You'll see that right here. And then the answer is going to be at the bottom of the box, written as a decimal. So we're going to write down that decimal. So it's going to be 0.7567. 0.7567. So that's going to be my decimal. And now I need to write it as a percentage. So I'm going to take this decimal point and I'm going to move it to the right twice. So the answer is going to be 75.67%. Okay, let's look at the next question. What percentage of the values is less than 70? Less than 70. Okay, so looking at the curve right now, I want all the area from 75 down. Let's see. I mean, less than 70. Okay, so that means 70 is going to be the maximum. I'm going to get rid of that and I'm going to type in 70. And then for the minimum, I don't have a minimum. So I'm going to get rid of the 61. When I get rid of that, it's going to become negative infinity right here. And then my answer is going to be at the bottom of the box. So less than 70. That means that you're looking at 70 on the x-axis and you're going less than that. So how much area is shaded? About 63%. So let's write that as a decimal first. So I've got 0.6306. And then I can write that as a percentage, 63.06%. So most of the area under the curve is shaded, but you've still got that 37% that's not shaded. Okay, the next question is going to ask, what percentage of the values is greater than 74? So greater than 74. What that means is 74 is going to be my lower limit. So going back here, I'm going to get rid of my maximum, and I'm going to let 74 be my minimum. And that's because the question is asking what percentage of the values is greater than 74. So you're going from 74 upwards. So you start at 74 on the x-axis and you go to the right, greater than 74. And then the decimal that you get is at the bottom of the box. So this one is going to be 0.1587. 1587. And that's going to give you 15.87%. That might not be a lot, but that's the area under the curve that gets shaded. Only about 15%. The rest of it is unshaded. All right, so let's look at the next question. How many of the values fall between 63 and 71? So 63 is going to be our lower limit, and 71 is going to be our upper limit. So 63, 71. 63, maximum is 71. So now you can see how much area is shaded under the curve. About 49% of it, right? So I'm going to write down my decimal that I get at the bottom of the box. My decimal is 0.4891. 4891. We can write that as a percentage, 48.91%. So going back to my question, it's asking how many values. When it says how many values, your answer is actually going to be a whole number. So how do I get that? I'm going to take this decimal I got right here, and I'm going to multiply it by how many values I have in total. How many values do I have in total? Does anybody know? 200, right? So I'm going to take that decimal that I got, and I'm going to multiply it by 200 to see what I get. So I'm going to put this inside parentheses, and I'm going to multiply it by 200. And then hopefully I can get a whole number out of that. So to do that, I go back to Desmos, I go to box 2, and I'm going to type in 0.4891, 4891, and then I'm going to multiply by 200. Close that up, and I get 97.82. If I was to round that to the nearest whole number, what would that be? $98, because that 8 is going to tell that 7 to go up to an 8. So 98 is going to be my answer. That's how many values are between 63 and 71. Okay. What does the next question say? How many values are less than 65? So less than 65. That means 65 is going to be my maximum number. So going back here, my maximum is going to be 65. I don't have a minimum, so I need to get rid of that minimum of 63. So now the minimum is going to be negative infinity. And then I write down my decimal. This one is going to be 0.3085. And then since it asks how many values, I need to multiply by 200 again. And when I do that, I get 61.7, which is rounded up to 62. So 62 values are going to fall less than 65. Okay. Question F is going to say how many values are greater than 66? I want you to go ahead and try that on your own.
When it asks for the percent of values, do you multiply the value with the number and then make that into a percentage?
No, that's only if you have how many values. When it asks for a percentage, you just take this decimal down here.
No, it says what percent of values is between blah, blah.
Okay, so you're talking about like this question up here, right? What percentage of the values? Yeah, your minimum would be 61, your maximum would be 75. It'll give you a decimal for an answer, and then you have to make that into a percentage. And you don't multiply by 200 because you only do that when it asks how many values. Right here. But if it's just asking for a percentage, you're just taking the decimal and then making it into 48.91%. Okay, so greater than 66. That means my minimum is going to be 66. My maximum is going to be positive infinity. And then the decimal that I get is 0.6306. But then since it asks how many values, I need to multiply by 200. So if I multiply by 200, I get 126.12, which is 126. So out of those 200 original values, 126 of them, which is most of them, are going to be above the 66 on the x-axis. Okay, go ahead and try number 2 on the problem set. When you try number 2, you're going to have to change your mean to 73 and your standard deviation to 7. So when you go back to your normal distribution, you're going to change your mean to 73 and your standard deviation to 7. So all I do is I change the two numbers inside the parentheses. The first number is always going to be the mean or the average. The second number is always going to be the standard deviation. Okay, now the last question that I did not get to was the z-score. Question 1 says find the z-score for 76. To do that, you're going to take the 76. I'll do it in box 2. You're going to take the 76 and you're going to subtract the average. Now the average was 68 in the last problem. So I'm going to subtract 68. I get 8 at the bottom of the box. But then I have to divide by the standard deviation. So what is the standard deviation for this problem? It was 6. So I'm going to divide everything by 6. And I get my z-score at the bottom of the box, 1.33. What I do is I round to the nearest hundredth place. So this 3 is going to tell this 3 to stay put. Okay, the z-score formula is going to be what we learned on Monday. That was z is equal to x minus the mean, all divided by the standard deviation. So when you're looking at a z-score like this, you're always taking the data point, which is x. This is my data point that they give me. You subtract the average, the mean. And then the last thing you do is you divide by the standard deviation. And that's going to give you your z-score. So going back to the problem set, go ahead and try number 2. And then go ahead and try number 3. Number 3, you're all going to get the same answer. Remember that the 3 sigma rule is going to be 68, 95, 99.7. So 1 standard deviation, 2 standard deviations, and 3 standard deviations.